Hi guys, I'm Michael. I'm from WAND with Brad and Richard, and today I'm going to be talking about a network access control and a Faucet-driven network. So we have a couple of problems with software-defined networking in our Faucet-driven networking that we can't dynamically restrict people's access. So that we can stick ACLs on different ports, and we can filter out traffic, and we can create tunnels, but prior to Chewie, there was no way for us to enforce some form of authorization and authentication onto a Chewie-based network, onto a Faucet-driven network. And so I've created this project with a number of other people at WAND and Victoria University called Chewie. It's a EAP-based 802.1x authenticator. It speaks radius in the back end and EAPoL on the front end. And it provides credential-based access control for Faucet networks, which means that we can configure on the radius end individual login credentials and tie that with role-based access control policies that can be pushed out to the authenticator and filter traffic and stick individual users on different VLANs and all that kind of stuff, all those goodies. So why deploy Chewie in your Faucet-driven network? You may want to deploy some form of secure network, and like I was saying before, with Faucet, that's not currently possible without additional plugins, which Chewie is one of. We support all major EAP-based methods in theory. I'll talk about that a little bit further later on. We also support IoT. So we have Mac-based whitelisting authentication using Mac authentication bypass. So if your device does not support challenge-based EAP methods, we can authenticate based on Chewie performing the authentication for the newly connected device. And as said before, we also do fine-grained access control, so we can put ACLs directly onto clients that are connecting. A little bit of background, if you don't know what EAP methods, EAPoL, radius, MAB is, we've got them all here because they're pretty crucial to what we're going to be saying. EAP is a framework for defining authentication protocols. EAP methods, which you'll hear, they are a particular implementation of the authentication. EAPoL and radius, they encapsulate EAP methods as EAP itself is not a line protocol. It doesn't know how to get from A to B. It can do the authentication stuff perfectly fine, but how do I discuss the things that I want to talk to with the person that I want to talk to? And then Mac authentication bypass is provided by Chewie, and it allows for authentication on behalf of a connecting device. Chewie's power. So Chewie gets a lot of its power by not doing anything. Chewie brings in, as we can see here, sorry, I'll speak louder, because as we can see here, EAP, the method itself, is encapsulated in either EAPoL or radius, and the authentication is not actually done on the authenticator, it's done on the authentication server. In our context, Chewie is here, and a radius backend server is here. As I connect to the network, I'm the supplicant. I go, hey, I'm Michael, authenticate me. And us as Chewie, we convert these EAPoL packets. We strip out the EAP methods going through. We stick them in a radius packet, and we send it off to the authentication server to be processed. That creates a challenge, sends back and forth, back and forth. If an EAP method is supported by the authentication server, we implicitly support it because it's tunneled. We avoid complex code that way. We don't have to do any local authentication. We can provide a number of the AAA resources that the authentication server provides. We can also receive a lot of AAA-based, but primarily radius-based attributes, which is how we define user-based VLANs and things like that when people connect, which is not available in EAPoL itself. So if it was EAPoL the whole way, we wouldn't have the opportunity for adding extra attributes to it. So user management in a Chewie environment, because we don't do the authentication, we can pass all of that off to the radius server. So if you've got a good radius server, you're going to get out-app support in the backend. If you don't, you're not. Free radius is available that supports out-app with some modules. That's the one that we're using for all of our testing environments. It's also available through our Docker Compose, which I'll talk about a little bit later. and you can attach user RBAC policies or user-based restriction policies. In our context, we use ACLs and VLANs, but yeah, I'm sure there's extra extension upon that, which I'll talk about at the end. How do we define it in pre-radius? I guess we go through various users. It's pretty self-explanatory, but I'll go through it. We've got hard-coded passwords, which you can store in either a radius or out at. And then we have these extra attributes that we've attached to each individual user. If we had LDAP in this particular context, you can group users together. You can store all the benefits of using LDAP. And they get forwarded with the radius packet as it comes back to Chewie. And we strip those out, and when it gets converted back into an EAPoL packet, or frame, sorry. So the connecting client does not see any of the extra attributes. We can interpret it as we're kind of the gatekeeper of their access to the network. These are just the specifics on which attributes that we use for that, and it's used for dynamic VLAN allocation and ACLs on authentication events. So I've discussed slightly over how EAP works. I didn't want to jump too much into it. I just thought if no one had any idea, it wouldn't be worth me standing up here. EAPoLs come in, and then this is what we see on the internals as we strip out the encapsulating EAPoL and radius protocol headers, I guess. Do note that this requires Supplicant software to be available on the machine. So if we're connecting via a dumb device, a printer, a phone, that kind of stuff that isn't EAP compliant, we can't get on the network. And so the only real alternative to a network that supports 802.1x is just to open up a port, which is kind of defeats the purpose on having a secure network, as we can just go plug wireless AP in, and now we have infinite access to your network. In practice, we have a whole ton of logging in Chewie. Chewie logs to the Faucet default log, and I've filtered this a little bit to make it a bit easier to see, but we can see all the different messages being sent to and fro from being received by Chewie. Chewie's generating the radius methods and sending them across back and forth. And this is the kind of stuff you'll be looking at when you're deploying Chewie. What about IoT? There are devices that don't know how to talk EAP, and that's why we've developed MAC authentication bypass. This is kind of how it works. So as I join a network, if I'm somewhat sophisticated, I'll send out a DHCP request saying, how do I configure to this network? Am I going to get an IP address? Am I going to get this and that? What we do is we block all traffic, including DHCP requests, to manage port. And we, once a port is marked as managed, we instantiate a couple of flow rules that will send all our EAPoL packets out, and it'll also send all of the DHCP requests from the managed port out through an NFV port, which I'll discuss in a second. And so authentication in this context is performed by Chewie on behalf of the connecting client. The MAC address is stripped from the DHCP request, and we use that as the user credentials that send off to Radius. So Chewie's architecture. Slightly different than any other implementation that I've seen for 802.1x in software-defined networking environments is that we don't use packet-in events to send authentication requests back to the controller. That's a big no-no. We don't want to flood our control plane. We don't want to do anything along those lines. So we have an NFV port, which all of the connecting clients traffic, or relevant traffic, so the EAPoL, the DHCP, if required, is sent from the control port into the NFV port, where it comes into Chewie. Chewie then sends it off to Radius or performs the authentication. And Chewie has a backend connection to the Faucet controller. This would tie in really nicely to the co-processor functionality that was discussed yesterday. When this was developed, the co-processor functionality wasn't available, but same kind of concept, sticking NFV-based functionality on your network and then directing traffic there for it to be processed. So the Faucet Chewie API is fairly straightforward. At this current time, it requires running on the same machine, so it has to be run on the controller device, but we're currently looking at performing gRPC and Protobuff for the API between Chewie and Faucet. That would allow us to have multiple Chewie instances regardless of Faucet. Also, you could have a number of different NFV ports, which allows scalability of your network. So you have a large network, you want to deploy quite a few controlled ports. Sorry. We tell a Faucet about successful auth events, failed, and log off events as clients are trying to connect to the network, and Faucet tells us about port up and port down, and that's the only information that we have looking to and fro Faucet. On successful auth events, we pass through the AAA radius attributes that we receive, and we use that to create filtering ACLs for the ports. So the allocation of ACLs and VLANs, what we've done is ACLs must be predefined in the Faucet config for them to be placed onto a port. We have an example of it here. We have a VLAN example as well. We don't create VLANs on the fly. They have to be previously defined. We also don't create ACLs on the fly. They have to be previously defined. However, based on user credentials provided, we allocate ACLs and VLANs on the fly to the ports. Chewie notes, at this stage, it can run independently of Faucet. So it is a separate project. It is not part of Faucet per se. And once we get the gRPC stuff running, the API will actually be separate and we'll be able to run it on a separate node. Saying that it is an 802.1x authenticator primarily built for Faucet. So you can run it independently, but it doesn't really do a huge amount. And deploying Chewie on your Faucet-based network. So Faucet is configured using the, Chewie is configured using the Faucet configuration file, the Faucet.yaml file. There are a couple of required fields to allow for Chewie to be instantiated on the Faucet network. However, if you have defined it correctly, Faucet will know and start Chewie for you. So you don't have to pull Chewie in or add any extra stuff. It will know how to do that for you. Also, unlike the a couple of the talks yesterday, like Poseidon, we don't change the Faucet configuration. So if Faucet restarts, that state is lost. And getting set up. So there are a couple of required fields. This is an example of Faucet configuration for Chewie. We have a .1x segment, which defines a radius IP, radius port, radius authentication requirements for Chewie as the authenticator to talk to the radius server. And then we just mark a single interface on the switch with a .1x equals true. And then that's now blocked by default until authentication is performed. We also have an extra value, which I haven't provided here, which is .1x_mab, which defines that it should be IoT compliant and perform MAC authentication bypass instead. All EAPoL traffic is forwarded to the NFV port. All other traffic is denied, except in the MAP context where DHCP is also forwarded. Try it yourself, use Docker. Seriously, use Docker. Otherwise, you'll be setting up a network by yourself. There is a whole ton of documentation out there, but that one command will at least spin you up an example network, perform an authentication for you. You can strip apart the Docker and see what actually runs. But it's the easiest way to go and configure it, run it on your local machine. With Open vSwitch, you can literally run it on your laptop. If you are interested on how it works, though, there are two sets of documentation for it. The Faucet documentation, if you're going to be using it, is primarily where you want to start reading. That's more of configuration, deployment, all that kind of stuff. If you want to start developing Chewie, which we'll discuss in a minute, check out the Read the Docs for the Chewie project. Adding Faucet to your deployment, like I was saying before, one or two fields in your Faucet configuration file, and Faucet will know to spin up Chewie for you. Logging and debugging. So if you do have issues whilst deploying Chewie, if you have no Chewie logs, you haven't configured it properly, there's no Chewie running. Otherwise, Chewie will spam your logs like there's no tomorrow. We will tell you state changes, individual state changes. We will say hey, maybe that wasn't an auth, maybe the packet was a little bit different, here was the packet that you got, a whole ton of information. So this has obviously been filtered quite heavily, but as you can see here, we're polling out to see if other people are on the network. We've sent an identity request message, we've received a message, we've sent radius packets. You can see the packets, which I've removed here. There's a whole ton of information. And then what you really want is to see if you get a success message. Or failure, I guess. If you're stuck, contact Brad. Or contact any of these mailing lists. Honestly, everyone's there ready to help. So it's very, very straightforward to get a deployment running. Overview. We have applying ACLs, we have applying VLANs. I've given a couple of example configuration files. There are a ton online. So they're also in all of our tests, there's a ton of configuration files that are available. It all really depends on how you want to set up your network, because we don't do the authentication. It can really be however you want it behind the back end. And you can deploy as many as you want. We have no vendor-specific requirements, which was kind of, ironically, a requirement for the project. And we also support dumb clients like IoT for NAC authentication bypass. The dream that failed, though, ideally, my plan was to create ACLs on the fly based on similar to flow rules. HPE is doing it. Cisco does it with ACLs, I believe, for their proprietary systems, but I couldn't find an example where it was kind of in an open standard. I found AAA attributes that were perfect for it, but ran into a number of issues with Faucet's allocation of resources on startup, which kind of was a bit of a pain. But after being enlightened yesterday by the Poseidon Fellows, I think there's a little bit of room for adding that into Faucet. However, I haven't done that in the last 18 hours. Yeah, I know. You can kind of get the gist. Maybe I want to deny in TCP from any to any. Maybe you could be even more specific by that. The way that I got the syntax was from the HPE documents. Plead for developers. We need developers. Obviously, there's like 3 people working on this project. Now I think there's 0. So cool functionality in Faucet. The coprocessor functionality that's been developed. It'd be really cool if we were compliant with that instead of our own proprietary version. Also, maintaining state on restart. We could add extra stuff into the Faucet configuration file, although I don't know how happy all the other developers would be about that, but that would be extra functionality. Or we could, instead of doing it directly onto the configuration file, look at running everything through Faucet Agent, which would kind of be fitting into the ecosystem of Faucet quite well. Also, at this stage, we require an NFV port to be on each switch that requires managed ports. I can't see any reason why we couldn't just tunnel that to a central port. It's just that that hasn't been developed at this stage. As well as something that would be really cool is encrypted channels. So quick side thing, 802.1x supports key exchange, and that's how it does it for WPA, encryption, that kind of stuff. If we could perform a key exchange, we could tunnel encrypted traffic from all of our managed ports into a co-processed decryption functionality and send it out a backhaul, which would allow for, I know that in the security industry, there's a lot of people moaning about network access control not really doing anything, because if I just spoof my MAC address, I can backbone on someone else's connection. If that connection's encrypted, I'm not going to be able to do that really. As well as in a software-defined networking environment, it's a little bit different because we can check for port up, port down, but say I connect the dumb switch to that, now I can't check for port up, port down, unless the whole switch goes away. So I can just get people backboning off that, or if I connect unencrypted wireless IP, and then spoof my MAC address is pretty easy to bypass. Whereas that would be really, really cool if we could do that. I'm Michael Washer. I'm a master's student at WAND, Waikato University. And here's my information. And if you have any questions, feel free to grab me or yell them out now. Yes, we do. Yes. So we filter based on MAC address. Yeah. Yeah. So that was kind of a design decision. Yeah. So we apply the ACL to that particular supplicant. So we call it port-based NAC, but it's not really. It's more individual supplicant based now.
Given where you go, we're going with we're talking about gRPC. You're, there is sort of disaggregating and standard. I could see that for the whole case, definitely want to have ready so that someone's solid implementation of the EAP methods. Authentication case, to me at least, it feels a little bit weird to have all of these things smell like X5. Say this map is good. Bad.
So the primary reason
you might want to build something else, another API. Is there an opportunity to do like a Chewie that's simplified to do just the case?
Yeah, so we've
radius?
separated. So yes, that would be easily applicable. So the way that we deal with state in Chewie is we use state machines based on the packets that are coming in. We have two individual sockets in the pipelines that are completely different. So if we wanted to turn off the EAPoL stuff or extract the map stuff completely, that would be perfectly fine. We just haven't done it, so it's more of an architectural thing. But yeah, they're 100% independent sections of code. It's kind of like one developer did the EAPoL stuff and one developer did the map stuff.
That's
yeah. So we had all the EAPoL stuff running with the Radius. So the main reason why MAB is backed by Radius is purely so we can store all the credentials in the same place, because we didn't really want to go, oh, well, here's one solution, and then we'll have all our MAB credentials over here, and we'll have all our EAPoL ones over here. And MAB itself still supports allocation of VLANs and allocation of ACLs. So if I connect a phone to something, and maybe I want all of my phones to have a particular ACL, that's all stored in the Radius server, and it sends it back to us, and we deploy that. So it's kind of nice to have everything centralized. But yeah, no, there's no reason why we can separate that out.
No, it was more about the sort of just the general idea. Is Radius the best? Clearly, when you rely on supplicants and clients, you're kind of tying Radius. But because MAC addresses and like MAB cases, by definition, you're saying you opted out of doing. It kind of frees you up to do any other thing other than maybe that's not pragmatic.
Yeah.
Now, how things have been architected to be able to create opportunity. That sounds like.
Yeah, so you can definitely do that. The main reason why we backed it by Radius was because that's kind of what the main vendors were doing as well. They were kind of tying 802.1x and MAB as kind of like this one switch it on functionality.
Yeah.
And both of them were backed by the Radius, and then you would set up something like free Radius and have your Mac as the user and encrypted password for authentication. So you actually just send off a Radius access request and get an access accept or denied or rejected. Sorry.
By the way, just a little bit of feedback. That logging feature, I think that is. I'm getting the access denied. Why am I getting it?
Yeah. So we dump
Radius servers sometimes,
tons of stuff,
or the LDAP servers sometimes operated by different.
Yeah. No, we log almost everything. We try and list packets with all their main values and all that kind of stuff. So.
Do I still get a smiley face when it's exit?
Yeah. I can't remember if that's still the case, but there was a number of outputs to the log that were just like, Chewie's happy. So, yeah, early stage. Yeah, exactly. Alrighty, any other questions? Oh, Bob?
It seems to me that the tunneling
So I was thinking more, yes, but it's more people backgrounding on those connections. That was the problem. So if I max food, and it'll just grab it and funnel it wherever you want it to go. But
with the tunnel.
okay, I would have to discuss with you.
I mean, like if it's an IP site, it's terminated. Basically, VPN.
Yeah. Sorry,
You're just
yeah.
plugging into it. Now, admittedly, that may be. I don't think there's a good. But for things like. Basically have any ports that you don't trust. Just tunnel to.
So that is a solution. The main reason that I was discussing this is because that's kind of what happens when you connect to a wireless network. And so it's really that final end goal, but you can run tunnels over a wireless network as well. But the WPA encryption, or like, the AES encryption that runs on the WPA wireless network, that gets terminated at the Authenticator. And that's why I was just like, could be an idea. Any other questions?
Question about your plan to save the state. That's often the
Yeah, so by not saving the state, it will can your flows, I believe. So
It fails closed.
yeah, it fails closed.
This is a periodic function as well. So
Yeah. So if you can't, if we believe you're not the correct user, based on a timeout, we will just spam you with a new challenge authentication, and you have to perform that, and we'll kick you off the network otherwise. So I'm not too worried about that. It was more to do with if we have something else running like Poseidon that was refreshing the config all the time. I haven't actually run them at the same time, so I don't know what will happen then. It would be interesting to store it in the Faucet configuration, but I'm also kind of wondering whether it's actually that relevant or whether we should have state locally inside Chewie, or how I haven't thought about it too much.
don't buy Faucet agent, one or other. It's probably authentication.
Yep.
And additional ACL Plead on that.
Yeah. We also have the functionality of defining default ACLs that you want across the board as well. So it doesn't necessarily have to be block all traffic, allow all traffic, unless they're XYZ user, and then we add particular ACLs for them that are defined in the radio server. You can go, well, by default, I want people to get access to the internet and HTTP, but we don't want, I don't know, router advertisements, because why would you want that? Any other questions?
what password did you use?
So we don't parse the EAP packet itself. So we parse the EAPoL packet, and we strip the EAP message out, and then we smash that into a radius packet and send it off. So we don't actually perform the authentication locally. I believe we do it manually. Yeah. So we have a couple of helper functions that extract the bits that we want, but just because we don't actually do a huge amount with the data, we just kind of like light stream it and then send it off. And especially because it's not actually going where we would perceive anywhere important, and it's not actually going directly to the controller, we don't have to pass any of that information. Any other questions? Alrighty, thank you guys for listening to me.